Let's look at how we would go about working a problem where we're told to simplify and find the value of, and we've got three different expressions raised to a power. So on these, we're going to be using PEMDAS, the order of operations, which tells us to simplify what's inside parentheses first. Well, there's nothing inside that we can simplify. Next, we're meant to simplify exponents. There are exponents that we need to deal with. This one, and this one, all outside of parentheses. When we have something raised to the first power, that means we just have that thing. So whatever's inside parentheses that's got a 1 outside of it, we can just keep that as it was to start with and take it outside of the parentheses. Now the little dots here are just telling us there's multiplication, although quite frankly the parentheses were enough to tell us that, but on the comp exam, since you're going to see the little dot, wanted to make sure you knew what to do with it. So now we're going to have 20x squared y times, and now we need to simplify this one. We need to deal with the exponent of 0 that is outside this parentheses. So you need to recall that anything raised to the 0 power is going to give you 1, unless it's 0. Can't raise 0 to the 0 power, but anything else to the 0 power will give you 1. And so this part simply becomes 1. This whole part right here, let me just mark them with the same color, this 20xy squared raised to the 0 power gives us the 1. That's right there. And now we're going to work on simplifying this final one. On this one, we have a -2 as our exponent. Now, if you were to work a problem where you had parentheses next to a number, we know that when we see parentheses next to a number, for example, if we see 5 times 3x minus 4, we know that we're supposed to take this 5 and multiply it times each term inside the parentheses. So we would have 15x minus 20. When we have a number outside of parentheses, that's an exponent, as we do in this problem. Now we're again meant to multiply. It tells us to multiply again because this number is outside of parentheses. But in this situation, we're going to multiply our number times each one of the exponents that we see inside the parentheses, and we need to make sure that we don't miss any exponents. And what I mean by that is if there's a number or a variable that doesn't have an exponent on it, like here we have the number 5 with no exponent on it, and so there's an understood 1 on that 5. So we're going to need to multiply our -2 times this exponent. So that would give us a 5 times, and now we're going to take 1 times -2, that will give us -2. And then we're going to take our -2 and multiply it times this exponent on the x. So 4 times -2 is -8, so now we have x to the -8. And then we'll have y to the, now we're going to multiply 5, these two exponents. 5 times -2 gives us -10. So now we could rearrange things and put the numbers together, and the variables that are the same we'll put next to each other. Now honestly, I'm just going to take this 1 and multiply it times the 20, and I get 20. Boom, done. So that's how we take care of the 1, is just go ahead and multiply it times something. So I've done the 20. I'm going to go ahead and bring this times 5 to the -2. Let me put it in parentheses. I think that'll make more sense. So I've brought that over here, but I cannot do anything with that in this 20 at this point. I'll deal with that 5 to the -2 in another step. Let's go ahead and write the x's together. So here I had x squared. Here I had x to the -8. And now we'll write the y's next to each other. And so here I had a y. I'd already taken care of that 1, so I wanted to mark it. All right, I have a y here, and I have a y to the -10 here. So now I've rewritten everything and put it in a place, in a logical place. So at this point, I can multiply, since I have x to the second times x to the -8. Remember, when we have the same base and we're multiplying things with the same base, we add the exponents. So we'll get to the number part in a minute, but for this x part, we're going to have x to the 2 plus a -8. And then for the y part, we're going to have y to the, well, what's our exponent here? We're supposed to add our exponents, but I don't even see an exponent here. Remember, if you don't see an exponent, it's an understood 1. So it'll be y to the 1 plus negative 10. And now let's go ahead and just rewrite our numbers. We did not do anything with the numbers on that step. And we're also going to skip doing something with them on this step. We're just going to leave those numbers like they are for one more step while we simplify what we have for our exponents here. So for the x's, I had 2 plus a negative 8. That gives me x to the negative 6. For the y's, in this situation, I had 1 plus a negative 10. That gives me a negative 9. At this point, when we are simplifying things, we do not want to leave, and we were told to simplify, that was the original directions, we do not want to leave any negative exponents. And so the way I can make the exponents positive is to move them below the fraction bar. Now you might be saying, I don't see a fraction bar, so make a fraction bar. The rule that we're using here is the one that says if I have x to the negative n, that is the same as 1 over x to the n. So we're bringing this below the fraction bar. Maybe you didn't see a fraction bar here either. We'll put a 1 down there. Because remember, fractions imply division. If you take something and divide by 1, you still get that same thing back. So here we made the fraction bar that we then moved that guy across, and it became a positive exponent when we moved it down there. So we're going to need to make a fraction bar. First of all, we'll put a 1 down there. We need to move the x's down because they have a negative exponent. We need to move the y's down because they have a negative exponent. But this 5 also had a negative exponent, so we will move it down below the fraction bar. When it crosses the line, it changes the sign. So we can think of it as crossing this line, which is technically a fraction bar, and that'll change the sign of the exponent. And so now, all that's left in this particular problem is the 20, in the numerator that is the 20. We are moving the 5 to the negative 2 down. When it crosses this line of the fraction bar, it changes the sign of the exponent. So that becomes 5 to the second. Same thing happens with the x's, changes the sign, makes it x to the positive 6 and y to the positive 9. Make sure you change your signs when you bring them down. Now, we're almost done, but our number part could be simplified a little bit more. For example, we know that 5 squared is the same thing as 25. And so we need to start thinking of that as being 25. Let me go ahead and rewrite that step, even though you could go all the way to the end from there. I'm going to write this out so you can see it clearly what happens here. I need to keep canceling my number part if I can, and I can because 20 over 25, well, 5 goes into both of those two numbers. 5 goes into 20 4 times. 5 goes into 25 5 times. And so in the end, we end up with 4 in the numerator over 5, x to the 6th, y to the 9th, and that is our answer.